Hey guys. So your lesson today is just some extra word problem practice. But in the notes last time, there was one type of problem that I didn't go over, and it's a rate, time, and distance problem. You talk about how fast people are going and for how long and how far and things like that. And so I just wanted to give you guys some advice on a problem of that nature, so when you do it on the homework, you have an idea of what you're talking about. So it says Karen and Andrew start from towns 164 miles apart and drive toward each other. So what that means is, I don't know which one is where, but you have Andrew and you have Karen. And they are 164 miles apart. Okay, and they're driving towards each other. Andrew goes at a rate of 40 miles per hour. Karen goes at a rate of 48 miles per hour. If Karen begins the journey 15 minutes after Andrew begins, how long after Andrew leaves will they meet? My advice to you, because all of these rate, time, and distance problems can be a little bit different, and I don't stress like charts or tables to set up word problems a ton, but with rate, time, and distance problems, I set them up every single time. And let me explain what I mean by that. So the way we find distance is rate times time, right? If you multiply how fast you're going and then times how long you've been going, you get how far you went. And so in a table, I'm going to set up rate, time, distance. And there's always going to be two scenarios, whether there's two people, like in this case, there's Andrew and Karen, or sometimes you're going to someplace and then coming back, or whatever the case may be, or you have two people going in opposite directions. This is kind of going to be the setup of your problem. And now we just have to fill in the boxes that we know. Well, it literally tells us the rates. We know Andrew's going 40 miles per hour. We know Karen is going 48 miles per hour. So they tell us that, which is really nice. What we don't know is how long Andrew was traveling for. And that's what this top box with the time is standing for. Like, we don't know this. We don't know how long Andrew was traveling for, okay? What we know about Karen, we also don't know how long she was traveling for, but we're not going to use two different variables. We're not going to do systems. So we're also not going to put X because they weren't traveling for the same amount of time. It says Karen begins the journey 15 minutes after Andrew. What that means is when they met, however long Andrew was traveling for, Karen traveled for 15 less minutes than that. The biggest mistake students make in this problem is they'll put X minus 15. And that's wrong because this problem is dealing in hours, like miles per hour. So anytime you're doing minutes, you have to change it to how many hours that is. Well, 15 minutes is a quarter of an hour. So it'd be X minus a quarter. So however long Andrew was traveling for, Karen was traveling for a fourth less of an hour than that. Now, the distance, I don't know how far they went, but the way we get our distance box every time, we multiply rate and time together. So 40x, and then 48 times x minus a fourth. And then we got to set up the equation. So we have to think, what's the relationship between these two distances right here? And again, this is where each problem just has their own little tweaks. Sometimes in a problem, the distances might be the same. Sometimes you add them and set them equal to something else. Kind of like in geometry, sometimes they would tell you two angles are congruent, and you'd set them equal. Sometimes they'd tell you they're supplementary, so you add them and set it equal to something else. It's similar to that, and we have to use context clues. You don't necessarily know if they met in the middle. All you know is they traveled towards each other, and they met at some point. So the only thing we know is when we add these two distances together, we should get 164. So that's our equation. When we add our distances together, I'm going to go ahead and distribute the 48 also. We get 164. And then we just solve this equation. So add 12 and yada yada, you get x equals 2. Now we always have to make sure we answered the question. It said, how long after Andrew leaves will they meet? So we're looking for Andrew's time. And this is where defining variables comes into play. Look at what X stood for. X stood for Andrew's time. So we answered the question. If the question said, how long was Karen traveling for, we'd have to take away 15 minutes from this. So we always have to look and make sure we answered the question. So Andrew will have been traveling for 2 hours. bottom line, if you guys see a rate time distance problem, I would try to set up a chart and use it to organize your work and help you out. And then try to think, okay, what's the relationship with the distances? All right, good luck, and send me an email if you guys have any questions.